Hey guys, welcome back to Monroe Tutoring. I just finished recording the limiting reagent video, and now we're just going to quickly cover percent yield. These things typically kind of are asked in the same unit. So let's just cover this. This doesn't take too long, but if you miss limiting reagents and you don't know stoichiometry, you guys have to check out those videos as well that I did, and then you're really ready for this. So, limiting reagent, I already discussed. If they give you two different reactants and they say how much of the actual product is yielded, whichever reactant yields less product, that's how much product you actually make, okay? But I covered that in the last video. But now, once you know how much product you actually make, that's when I say actually, I should have phrased it as that's how much you can theoretically make. But in a percent yield problem, they may say something along the lines of, 3.72 moles of lithium are reacted in excess nitrogen gas, meaning we have more of this than we need, so this is not the limiting reagent. This will be the limiting reagent. So 3.72 moles of lithium are reacted with excess nitrogen gas and produce 1.12 moles of lithium nitride. What was the percent yield of this reaction? And so the idea is they're giving us how much lithium we're going to use in the reaction. And they're also telling us how much we actually got of the lithium nitride. So like now what do, right? There's, at first glance, it looks like there's nothing to convert to because they gave us this. If we did some stoichiometry, we would get this, right? But that's not the case. Because when we do the stoichiometry, in other words, converting from quantity of this compound to quantity of the other compound, like the product in this case, that's the theoretical yield, or the theoretical amount that you would either need to react with, or the theoretical amount that you get produced. But now when they're telling us how much was produced, they're giving us the actual amount that we got. So it's like, if you're looking at your car and you get 30 miles per gallon, theoretically, and then you pump it up with gas and you drive around for a while, and then you do the math and you only got like 26 miles per gallon. The theoretical that you should have gotten was the 30, but the actual that you really got was the 20, whatever I said, 26 miles per gallon, okay? So reality and the theoretical, quantity that you should get can differ. And that may not have been the best example, but it's an analogy, right? So now what we're going to do here is we're going to take the given information from the reactant. We're going to do our stoichiometry in order to get the theoretical amount of product that we should have gotten. And then we're going to look at, okay, what percentage of what we theoretically should have got did we actually get? So really quick, let's just jump in. And again, I've taught you guys how to do the stoichiometry stuff, whether you start with grams and you want grams, or you start with moles, you want moles, or something in between. But we're going to keep this simple for this purpose here. So we take the given information, 3.72 moles of lithium, and we do our parentheses as we do every time. And we're going to take the mole ratio. Remember the coefficients, that's the mole ratio. So it's 2 moles of lithium nitride for every 6 moles of lithium solid. And we want to cancel moles of lithium, so moles of lithium goes in the bottom. We have 6 moles of lithium over here, and the 2 moles of lithium nitride over here. Let's do this math. And so we have 3.72, and remember we multiply by what's on top, divide by what's on the bottom. Let me cancel out my units while I'm here. So the only unit left is moles of the product, lithium nitride. So 3.72, whoops. Okay, this times 2 over the 3. And we get 1.24 moles of lithium nitride. And so this is the theoretical yield. They said that we have excess nitrogen, so that's not the limiting reagent. So basically, all this is going to react theoretically. And this is how much lithium nitride we should have gotten in a perfect world where everything reacted perfectly. But of course, things happen. Reactions can not yield the theoretical amount. They typically don't. due to various factors. You know, stuff gets dirty, things aren't mixed well enough, whatever it is, impurities, all sorts of reasons. But this is our theoretical yield. What they gave us is the actual yield. That's what they told us in the problem. They said, if you react to all this stuff, this is how much you actually got. What's the percent yield? So this is what we actually got. This is what we theoretically should have gotten according to doing the stoichiometry. And now we just need the formula for percent yield. And it's really just, I mean, if you can logic your way through it, right? So we want the percent yield, which is going to be the actual that we got, that's over the theoretical amount that we should have gotten, right? Because the theoretical amount is the full amount. And then the actual is a portion of that. We got less than the full amount. So really, it's quite simple. So I'm going to just write over here, percent. I'm going to just do a big Y for yield is going to be equal to the actual over the theoretical. And then times 100 in order to make it a percentage. That's it. So it's super simple. So we just take the actual, the actual amount that they told us we got, and that's 1.12 moles, and that's over the 1.24 moles that we theoretically would have gotten. We multiply that by 100 in order to make it into a percentage, and let's see what we get. So it was 1.12 divided by 1.24, and that comes out to 90.3%. I'm just going to bring this up over here. That's 90.3%. All right, guys, so pretty simple. If you can already do the stoichiometry and, you know, you can go from quantity of one thing to quantity of another, whether they're giving you moles or grams and they want either grams or moles. As long as you can do all those things and you understand limiting reagents, this really is the simplest part of the problem. A lot of times I've seen this as part like E or D of a long multi-part problem, including all sorts of stoichiometry, limiting reagents, and then finally percent yield. And that's it. All right, guys. So if these videos help you, please give a like, follow, share, and save so you can review these again later. And then if you want to go above and beyond, you can go ahead and show your support and patronize me. And if there's any other topics you'd like to see me cover that I have not gotten to yet, go ahead and comment down below, and I will try to prioritize them. I want to help you guys out so you do well on your exams. And thanks for joining. I'll see you guys in the next one.